Should I start? Okay, good afternoon. My name is Jonas. Maybe some of you have seen me before. Today's lesson is about cube roots, and yeah, you will learn about how to simplify a cube root. And well, we start with the index of a cube root is always 3. The cube root of 64 is written as this, and soon I will show you what everything is called. So what does the cube root mean? The cube root of a number is the value when multiplied by itself 3 times gives the original number. So this is what it's called. You had the radical sign, you have seen it before. Then if you have seen it with number 2 here, but now when it's cube, this will be number 3. This is the index. And then you have the radicand here, and you will soon see more about this. So perfect cubes. If a number is a perfect cube, then you can find its exact cube root. A perfect cube is a number that can be written as the cube raised to third power of another number. So let's see here. What are perfect cubes? So 1 raised to the power of 3 is equal to like 1 times 1 times 1, and that is 1. And this is another example. 2 raised to the power of 3 is equal like 2 times 2 times 2, and that is 8. And so on. You have 3 raised to the power of 3, that is 27, and so on. So all these are perfect cubes. So now we get to some examples. So the cube root of 64 is written like this, and the answer is 4. Why? Well, because 4 times 4 times 4 is equal to 4 raised to the power of 3, and that is 6. No, it's 64. Okay. And if you have a negative number here, the answer here will be negative, because minus 4 times minus 4 times minus 4 is minus 64. If I'm doing it too fast, I want you to write in the box here if there is something you don't understand. I will try and explain it a little bit slower, but you will see more examples, and I think you will get it finally. So we have more examples here. 27 is the same as 3 raised to the power of 3. And in the same way, the cube root of 27 is 3. And you have the same here. 216 is the same as 6 times 6 times 6. And that means that the cube root of 216 is 6. So, and then you can do the same thing with fractions. Just the same. 64 is 4 raised to the power of 3, and 125 is 5 raised to the power of 3. That means then you do the cube root of this fraction will be the same as 4 divided by 5. So and then of course you can have letters involved, and it's the same thing. In this case 8a raised to the power of 3 is simplified as 2a's raised to the power of 3. That means that the cube root of 8a raised to the power of 3 is the same as 2a. And the next one here, 27, is 3 raised to the power of 3. M12 is M4 raised to the power of 3. That means that the cube root from this expression is equal to this. And then we have minus 64 y15, and that is the same thing here. You look at minus 64, that is minus 4 raised to the power of 3, and y15 is y5 raised to the power of 3. And that means that the cube root of the whole expression is the same as this here. And once again, if there is something not so clear, you can maybe try and give some comment in the box, and I will try to explain better.
อ้าวตอบหน่อยสิครับเงียบกันหมดเลย
Then you can simplify cube roots. Not all numbers or expressions have an exact cube root as in the previous examples. If a number is not a perfect cube, then you might be able to simplify it.
โอเคแหม
We will look at some example of that. To simplify a cube root, write the radicand as a product of two factors where one of the factors is a perfect cube. You will see that later, how we do that. Then extract the cube root of the factor that is a perfect cube, and the factors that are not perfect cubes will remain as the radicand. And now we will see some example of this. So first of all, we have the cube root of 54. 54 is not the perfect cube, but you can make 54 is the same as 27 times 2, and 27 is a perfect cube. So then you can extract and extract this out. Then it will be 3, and then you have the cube root of 2 left. And this is another example. 640 is not the perfect cube, but you can make this into 64 times 10, and 64 is a perfect cube. because that is 4 times 4 times 4. So then you lift it out, you extract it, and you only have 10 left in the cube root. And now we have a little more difficult expressions. We have 500 A7 B5. And now, okay, first we have to look at 500. Can we simplify this to make one part of it as a perfect cube? Yes, we can, because 500 is the same as 125 times 4. And then we have A7. We can simplify this as A6 times A, and I will show you later why we do that. And then we have B5, and you can simplify that as B3 times B2. So now you have 125. You can extract. Now first here they put this here together, 125, and then they put A6, and then they put B3, and this here you can simplify, and the rest that is still left is 4 and A and B2 they put here. This will still be in the radical sign, but this here now you can simplify this, because this will be 5A2B from this cube, and still left in the radical sign the cube root of 4AB2. We'll look at this again. 500 you can simplify to 125 times 4, because 125 you can extract later as 5. Then you have A7. You simplify that to A6 times A, because then you can extract A6 to become A2. And then you have the B5, which you simplify as B3 times B2, because then you can extract B3 to become B. Then you have simplified this whole expression. Okay, I can go back to this again later, but I will continue now. Not all cube roots can be simplified. For example, if you have the cube root of 30, 30 is not a perfect cube, and you cannot, there is no factor in 30 that has a cube, that has a perfect cube. So in this case you cannot simplify it at all. So then it will stay the same. Well, we have some other things to show you here for clarification a little bit. This is one cube and 8 cubes. This you can see is the perfect cubes. 27, 64, 125. So they can call the numbers 1, 8, 27, 64 and 125. They are called cube numbers. So you can call it 1 cubed or 1 raised to the power of 3 or 1 to the power of 3. That is also called 1 cubed. And in the same way you can say 2 cubed. You can make that means 2 to the power of 3. And 3 cubed and 4 cubed and 5 cubed, the same way. It's just another way to express it. Well, we go on. Now we have a little exercise here. We have 27,000 square meters. So what will the sides be in this cube? Anyone? If you know, you can type in the answer. Anyone knows the answer here for the side? 30. Yes, that's correct. Because 30 times 30 times 30 is 27,000. Yeah, and this is also the way to describe what it's called. 5 cubed will be 125. And when you go from 125 to 5, it's cube rooted. So the cube root of 125 is 5. And 5 cubed is 125. It's a way to express mathematically. And this is, of course, it's called the cube root of 125 is equal to 5, or is 5. Okay. This is here is squares, and they say it's positive only, so all numbers, if you square them, they will be positive. But okay, we use index notification to show repeated multiplication by the same number. For example, we can use index notation to write 2 times 2 times 2 times 2 times 2 as 2 raised to the power of 5. And this is called the base, and this is the index or power. This number is read as 2 to the power of 5, and it's equal to 32. So the base and the index. So if you have 6 to the power of 2, it's 6 times 6, it's 36. And 3 times to the power of 4 is 3 times 3 times 3 times 3, it's 81. And if you have a negative number and you have an odd power, then the answer is negative, like you can see here. This here is another example, and if you have a negative number, the same here, to an odd power, the answer is negative. But if you have a negative number and an even power, then the answer will be positive. So in this case, minus 4 to the power of 4 is minus 4 times minus 4 times minus 4 times minus 4. That is equal to 64. It's not that difficult. I think you know maybe already this. So we go on. So when you use the calculator, then you have of course a key to use when you calculate about this. So if you want 7 to the power of 4, then you put in 7 and this dot here and 4. And maybe you have used this already before, but most calculator have this, and then you get the answer 2401. So then you have the index law. When we multiply two numbers written in index form and with the same base, we can see an interesting result. For example, 3 to the power of 4 times 3 to the power of 2. Then you see here, you take 3 times 3 times 3 6 times. That means it will be 3 to the power of 6. That means that you add the indices. So you have the base. If you have the same base, you just add the indices. Another example, 7 to the power of 3 times 7 to the power of 5. Then you have the base, and then you add the indices. So 3 plus 5 is 8. So in this case, 7 to the power of 8 is the answer. And the second index law, it's about when you divide. When we divide two numbers written in index form and with the same base, we can see another interesting result. For example, 4 to the power of 5 divided by 4 to the power of 2. Then you see here you can simplify. So the answer will be 4 to the power of 3. That means that you can subtract the indices. So 5 minus 2 is 3. Another example, 5 to the power of 6 divided by 5 to the power of 4. Then you have 6 fives up here and 4 here, and when you simplify you have 2 left, but I think so 1 there and 1 there, for example. So 5 to the power of 2. So in this case you take 6 minus 4, the indices here, and then you have the answer. So it's quite easy. That is the second index law. So now we have some example here. This is a special case. You have 6 to the power of 4 divided by 6 to the power of 4. That is 1. So how can that be 1? Well, first you use the second index law. So the index is 4 minus 4. That is 0. So 6 to the power of 0 is 1. So that means in this case, in fact, any number raised to the power of 0 is equal to 1. For example, 10 to the power of 0 is 1, 3.452 to the power of 0 is 1, and blah 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 to the power of 0 is 1. Because when you see the fraction, the we go back here. If you have the same amount of 4's here divided by the same amounts of 4's here, the answer will be 1. And if you choose to have another number, for example 6 or 10 or 2.5, it will be the same way. The answer will be 1. So everything to the power of 0 is equal to 1. Like they show here. Okay, sometimes you get negative indices. If you have 3 to the power of 2 divided by 3 to the power of 4, then you get 2 minus 4, that is minus 2. So here 2 minus 4 is minus 2. And that means that it will be in the denominator, the 3 to the power of 2. So when it's minus 2, it's in the denominator. So 3 to the power of minus 2 is the same as 1 divided with 3 to the power of 2. And you can see other example of this. For example 6 to the power of minus 1, that means 1 divided by 6 to the power of 1, but you don't have to write 1 here because it's the same as 6. And then you have 7 to the power of minus 4 is equal to 1 divided by 7 to the power of 4. So you have the minus, the index, if that is negative, then you get in the denominator the positive index. And here they write it algebraically, but it's the same way that we have shown before, but now they use it with letters instead. So you have the same base. In this case they show it as an A, the same base, and then you have the index here and the index here, and you add them when you have the same base. When you multiply, you add the indices. And in the same way, when you divide the same base, you take the first index minus the second index, like they show here. Then you have the special case when the index is 0, then the answer is always 1, no matter what it says here. Then you have another special case when it's when the index is negative, then it's 1 divided by this base here and the index, and in this case it will be plus 1, but they don't write it here because they don't have to. So it will be a fraction. So that means if you put an n here, that means any number you put here. You have a and the index is minus n, then that it's the same as 1 divided by the base a and the index n. I see we still have 14 listeners. That's good. Nobody has left yet. And now we have a little question for those who are still awake. Um, we have 62 to the power of minus 1 divided by something, and then you have the answer 62 to the power of minus 4. So what will it be in the box? If there is someone who still is awake. 62 to the power of 3. Excellent. 2 fast awake students. That is correct. So that was it about this lesson. Many things, and I hope you get most of it. But of course, the best way to learn is to make some exercise yourselves. And but if you have some question, maybe this was the most difficult of the whole lesson. This is a bit tricky to find. First, to simplify, to find the perfect cube, and well, this takes a bit of practice. I think this is the most difficult. So I will leave this page here, and you can look at it a little bit longer. Because if you get this, then you absolutely know everything about this lesson. Yeah, yeah, I think good students. Okay, then I thank you very much for your attention, and have a nice day.